I was chatting with Dale and Dawn this morning, and they've actually had so much early interaction with Google's map and web mapping properties, including Google Maps when it launched as well in 2005. And Google sometimes, we're a pretty big company, and sometimes a bit tough to get a hold of. So I think we finally relented and have been working really successfully with them in recent years. And one of my colleagues, Dylan's here as well, and can speak to, I think, some of the great relationship we have going with them. So I'm based in Toronto. I work in the Canadian team for the enterprise side. That's the team that supports business and government for the use of our maps in Canada. And about a year ago, next week actually, it was June 20th of last year, a colleague and I were in Calgary, and we were hosting some executives from the energy industry, and we were at an event. There were about 50 people there, and my colleague and I were presenting and kind of hosting a panel and some discussion, and the phone started to ring. Everybody's cell phones were buzzing throughout the whole event, and slowly over the course of an hour or so, they dropped like flies. The event went from 50 to maybe 10 people, and we're kind of thinking, what have we done wrong here? And it was actually the night of the floods in Calgary and in the Alberta area there. And over the course of the next 24 to 48 hours, the floodwaters really rose. Everybody was getting phone calls about their basements flooding, about their parents' homes in the outskirts being endangered. And Google actually worked, our crisis mapping team, I'm not sure if you're aware, we have a .org group that's called, that does a lot of work in crisis and emergency management. And we worked with a lot of different agencies at the city level, at the provincial level, federal level. We worked with crowdsourced data, and we worked with data from private businesses, and we mashed all this together and put together a crisis map and stood it up on Google's map engine infrastructure for the world to look at. So over the next few days, immediately following the floodwaters, over 300,000 unique visitors came and hit this map. And so companies were using it to help plan safe places for their employees to relocate to. Individuals were using it for just getting real-time updates, essentially, on what bridges and roads were open and which were closed, and looking at different facilities. There was even a layer showing gas availability at certain stations when there was some concerns about fuel around the event. So it was a great example of business and government and private citizens all coming together to put together relevant real-time information on a map. But it was hard. It was really, really hard. The data conflation issues and just the management issues and the interoperability issues would have been far better served with a platform like FME tied into this map. Now, we've since taken some steps to make sure that that's working better. So really what I want to talk about today is in events like that, why interoperability and usability and scalability overall are really critical to standing up maps that any of your stakeholders are going to view, especially if they're going to be public-facing. We'll talk a bit about how Google came to be in the mapping space. I mean, we were first and foremost in the business of search and of index, but it turns out that location is just increasingly important for all internet users. We have some data that shows that about a third of all search results out there have some kind of contextual question that comes with it. Over 40% of internet users, all today make use of Google Maps and our Maps API in some way, and we have over 1 million instances of our Maps API actually being embedded in websites around the world, which is pretty exciting. Interestingly, over half of all Maps usage is actually on a mobile device, which is a trend that we're seeing more and more. We see mobile basically eclipsing desktop use in almost every facet of our business. But all this tells us that location is really important. And so one of the things that's really happened with the consumer familiarity that comes from a platform like Google Maps that's been really well adopted out there, and from all sorts of consumer mapping platforms that are available in the market, is that it's done a really interesting thing. We're standing up a really familiar, really deep, rich, 3D realistic map of the world, and we're trying to get better at it. We collect more high-resolution imagery in a week now than we had in our entire archive in 2009. So we're collecting new data all the time, and we're trying to keep it accurate and improve it constantly with thousands of edits happening at any one time in a day. And what that's done is it's made mapping, if you compare it to 10 years ago, it's made it kind of a household tool. Almost anybody can use it. And that consumer familiarity has done a really interesting thing. It's transformed the way that businesses and government organizations are using maps as well. Because outside of the GIS department, there's now a familiarity with the value of spatial. And all of you, I know, have some familiarity with that. It's Google's contention that maps are, in fact, the next document type. If you went to a business user, just anybody in an organization in the mid-'80s, and said, we're going to give you this great tool, it's a spreadsheet, Lotus 123 or it's Excel, and it's this beautiful tool. And what you can do with it is all sorts of things that are really going to help you as an office worker in productivity. They might have looked at you and said, well, you're crazy. I mean, that's a tool for accountants. Right? Isn't that what a spreadsheet's for? That's not for me. I don't need that. Cut to today, and absolutely everybody uses spreadsheets. I think most of us use spreadsheets in some way in our daily lives. We think maps are like this as well. If you had a choice between surfacing a data set that had addresses in it or any kind of geocode as a table or surfacing it as a map, we think that maps are essentially the way that people want to consume that kind of data. At home, at work, this is the way that people want to visualize it. So traditionally, only a small set of business users could really consume this kind of map knowledge, this kind of spatial knowledge. In fact, there's some good data around it. BCG did a study that shows that roughly half of the companies out there right now use some kind of web-based mapping service in their business today. But interestingly, only about 5% of all of their employees have any familiarity with the tools used to build it. This is you guys. These are the geospecialists. Google sees the real opportunity in reaching the other 95% of the marketplace. And essentially, it's not even so much from a market perspective, but think of all the great things that people could do if they had the same access to complicated, dynamic data sets that you guys are currently manipulating today with FME. If they had the same access to holistic data layers, like the database available through Google Maps, and if they could put it all together and mash it up easily, that's where we see the real opportunity. So that brings us to kind of what we're really excited about and the theme of what we wanted to talk about today, which is mapping at scale. So let's talk about a little bit about what that means. We've got a concept that came out of our own serving of the consumer-facing map data. If you look at the data maps.google.com, it's served at scale, and that means we take large amounts of data, and we essentially pre-render tiles at various resolutions, and we serve them at high speed throughout the net. We actually try to SLA the performance for that. We try to keep it really, really fast. And people want a fast, easy, zoomable user experience because they demand it now. The consumer familiarity with maps really kind of wants a low latency, high performance experience at all zoom levels so that they can experience maps that way. In order to stand that up, we had to build some amazing infrastructure. And we're really fortunate because of our consumer business, we have great access to infrastructure. And so essentially Maps Engine is an effort to make that kind of infrastructure for managing spatial data available for all the data that Google doesn't have, which is all the data that you guys work with. We just have the tip of the iceberg. And so Maps Engine is a way of mashing up your data and your stakeholders' data with Google's geotechnology and serving really elegant, easy-to-make maps at scale. It's a platform as a service type concept. You pay for what you need, and you essentially put some up there. There is a consumer-facing property. You can go to mapsengine.google.com, and you can actually start one today. And we can talk with you afterwards. Some of my colleagues are here if you're interested in figuring out how to do that just with your own account get started. So this has been in use already for a couple of years, and a lot of agencies are using it, commercial agencies, businesses like FedEx. NOAA's done a really interesting thing. So one of the groups in NOAA, the NGS, the National Geodetic Service, essentially captures high-resolution imagery after events. And they have to do it for all the coastlines in the continental US, but they also do it immediately after storm events, hurricanes, tornadoes, and that kind of thing. So they have high-res aerial imagery. And they've been serving it through GIS platforms in the web for some time. But I have a quote here from NOAA. It says, using Maps Engine was the first time that NOAA made a non-emergency response data set available as a GIS service in less than 24 hours. Up until recently, the ability to host and serve data this way was encumbered by their limited staff resources and the requirement that NOAA own the server software and hardware. But in the cloud, all these limitations disappeared because populating the data stores is pretty much as easy as checking email. This is a direct quote from the group at NOAA. FedEx stands up their store locator on Google Maps Engine, which you think would be kind of weird. You want to find your local FedEx. You go to fedex.com, and there's a little store locator. And looking at your IP address, they can pop up your closest one. But they did it for an interesting reason. FedEx has a massive supply chain challenge all the time in managing the movement of all the packages that they do. When a storm hits a certain area of the continental US, they now can use Maps Engine to, in real time, change the store hours so that when somebody goes to their web property, goes to fedex.com, they're getting the actual dynamic real-time store hours being pushed to that user and being pushed to mobile as well. And they're standing that up at scale using this platform. Amtrak is using it for the real-time management of the trains and the positions around North America. Really cool stuff. So those are kind of out-of-the-box push examples of hosting some of their data and using that scale in Maps Engine in order to do things in real time. But we think that's just the tip of the iceberg, and we're really interested in working with people like yourselves to do some cool mashups. Here's a great example of one being used by a transmission and distribution utility services company, where they've mashed up utility assets, this is some of the lines in blue and red, with Google Street View in the background, in a front end built on Earth, the platform, mashed up with work order data for some of the field service crews who are going out to see the offsets between, say, a cable company's asset and a utilities company asset, because there are all sorts of regulatory challenges with the distance between some of these high-energy power lines. So this is a mashup that was stood up on top of Google Maps Engine and has lots of performance. So people can hit this at high scale and get the kind of performance using their GIS data. Now, this gets to, I think, a little bit of why we're excited about this partnership. Google's a cool company. We have a pretty big problem here, though. Despite this entire story around GME, around Google Maps Engine, we have a last mile problem. We can get the data out of the cloud, no problem. We've got that kind of resource and that kind of horsepower to do it. But data ingest and management is a real deal breaker. And for us, working with FME is a game changer. It's a massive game changer. We're looking at ways to basically be interoperable with all of the GIS platforms out there. I mean, we've built free toolbars that you can download for QGIS, for ArcGIS, and just embed inside the browser and publish direct to Google Maps Engine for that. These are free. You can download them from our site. But what we think is really important is the way that you would interact with data from dynamic sources. And I think that's really where the partnership with SAFE is really interesting for us. So what? Why is it important? Let's get some concrete examples here. In the US, there is a state-level Air National Guard in every state. And they acquire rapid, actionable emergency response, high-resolution aerial images after natural disasters and any kind of an event. So a tornado blows through the Midwest, and each individual state would stand up an aircraft, and they'd be the first on the scene. FEMA has taken ownership nationally for aggregating all of those images and for managing that program in a more national way. And they serve it. This is the map that they typically serve, and it's served to a niche audience of responders, several hundred responders from each of those Air National Guards. It's not particularly suited performance-wise to the kind of traffic that we've been used to in some of our efforts I mentioned earlier from our crisis mapping team. So Google's emergency response crisis team has stood up maps in response to not just the Calgary floods, but the tsunami in Southeast Asia of last year, and the Hurricane Sandy response, which I think was one of the largest amounts of traffic we've seen on that service. This is critical imagery. This is life and death stuff here. This is captured before you see a news helicopter on the scene. This is the data that we use in GME with our crisis team. Before FME, Google's crisis team would wait. We would watch the FEMA site actively, F5, refresh constantly. We'd download imagery as it became available, and we would process it for readiness and then stand it up in Google Maps Engine for our crisis efforts. And that's not quite as scalable. The whole question of Google is, how do we make that more scalable? So not quite where we want it to be. With FME, we can now auto-ingest this data and surface it in Maps Engine instantly for availability to intense traffic, tens of thousands or hundreds of thousands of concurrent users if we need. So we're excited about this. The scale question is something that we think is really critical. So what does that really mean? If you're building maps that leverage partner data of some kind, that's great. Where does that data live? What infrastructure is it living on? What is it going to cost, not so much you, but the host of that data? What's it going to cost them, both computationally and perhaps even dollar-wise, to access that data? Should that data be mashed up into a beautiful, elegant, and really critical and relevant map? What's it going to cost them to stand that up? This chart shows traffic across the map that we stood up before and after the Hurricane Sandy landfall on the east coast of the US. We're not really big on specifics here. We don't give you the left axis here, but millions of people access this map pretty much immediately. For a rough idea of numbers, over 25 million people were displaced by Hurricane Sandy, and they were all looking information about their home, their family, and their business. This is something we've learned through our crisis efforts. Some other interesting data. Since 2010, our team has seen, pretty much with minor exception, the internet remains remarkably robust after an event. This is surprising. It was surprising to us too. Haiti, which you could argue, the earthquake in Haiti, you could argue that was possibly a worst-case scenario in terms of local infrastructure. The internet never went down at all, and it was back to full capacity within a couple of months, and that was the worst-case scenario. In a place like the earthquake in Christchurch, for example, in New Zealand, it didn't go down at all. In fact, we didn't actually see a change in daily traffic patterns. Those are day-night traffic patterns on the map. In Christchurch, the internet went down. The internet stayed up the entire time, but voice and SMS went down, which is interesting as well. So one of the things that we found is that people were instantly accessing all this on mobile. There's a chart I don't have up here that basically says from event to event, our crisis team has mapped increasing mobile traffic with each concurrent event, a trend toward mobile all the time. So what's your data sources infrastructure if you're standing up a public-facing map? This is ours. This is Google's infrastructure. We're a company of big numbers. We index the entire internet every 30 minutes. We refresh 20 billion pages a day. We process 100 billion search queries a month, provide email for 425 million Gmail users. That number's a little higher now. And we process 72 hours of video uploaded to YouTube every minute. So in terms of scale, we have lots of it. And so when we're talking about really critical, mission-critical events where you really want to be careful about the cost and both computationally and dollar-wise of the data, we think it's important to stand it up on a scalable infrastructure. Let's give an example here. New York City publishes all their 311 data. This is all the service requests. My neighbor's dog pooped on my lawn. I'd like for more frequent snowplow service, that kind of thing. They publish all this as a real-time open data layer. A colleague of mine, Sean, you want to wave? Hi, Sean. You should go and meet Sean. Pretty bright guy. Sean started writing a custom Python application. He was working with the city of New York to do the data translation out of this service, because this is not particularly scalable here. But then Dale and Don and the engineers at SAFE actually gave us access to a license for FME. And instead, Sean just did this. Now, Sean's a pretty smart guy. So he learned, I'm going to brag about you here. He learned how to use FME in about a day, and he stood this up in a couple of hours, which is pretty cool. But this is the kind of thing that you could stand up really fast. I'm actually going to see if I can bring up the real example here. See that? So this is the map that Sean put together using Maps Engine and FME. And let's go and see, these are the, I've turned on here the last 48 hours of the actual open data layers for the 311 service request published out by the city of New York. And let's have a look at an individual one here. What was this? Somebody reported a dead tree, a dead or dying tree on their lawn. And you can see that these are actually very, very fresh layers, right? So this is June 10th. See a couple others in here. Street condition. There's a pothole. It's a pothole in my neighborhood. They've reported it. Now, the utility of an open data strategy, we've been hearing from some of our partners, open data is fantastic, but if it's not easily accessible, if it's dynamic, changeable data, and it's not surfaceable, then perhaps it's not really meeting some of the goals of the open data strategy that kind of underlay it. So we're really excited about these kinds of mashups that's possible. I mean, that was just one example that a colleague of mine put together in a really short period of time. Which brings us to discovery. So you've ingested all of your data. You've built a scalable, elegant map. Now what? Who can find it? So we have lots of data. Google's got fantastic stuff. We've got all that high-resolution imagery. We're doing constant map updates to our database. We have a POI layer where we're constantly updating information about businesses and homes and public spaces. But Google Maps content is just the tip of the iceberg when it comes to relevant spatial data. We think we have a tiny fraction of the global spatial data that's out there. And you think of all the use cases around it. This is where you work and live every day. So caribou migrations, a map on those. That's not in Google Maps. You wouldn't be able to find that if you go to maps.google.com. Evacuation areas, should there be a crisis, not available on Google Maps. Neighborhood bear sightings. Sure, this is an issue if you live somewhere in the Lower Mainland. None of these are available immediately in Google Maps on our consumer properties. So that's the challenge here. So we wanted to introduce, we've just launched it, Google Maps Gallery. You can go to maps.google.com/gallery if you want to have a look at this. Google Maps Gallery is essentially a place for authoritative content sources to be published and easily discoverable and searchable by those out in the public. So it's basically a way of saying, okay, I'm a citizen of Vancouver, and I've had these 4 big gallon jugs of used motor oil sitting in my garage. I like to change the oil in my old car. And I need to know where to drop them off. Now, the city probably has a household hazardous waste drop-off map somewhere within their property. But we'd like to help make that map more discoverable, because let's be honest, you know what most people do? They don't go to Vancouver.com and type in and go and search around for that map. What they do is they go to Google and they say, use motor oil drop-off. Now, Google might pick up their IP address and return the address for the local Canadian Tire in the area, perhaps, or for the local shop where they might drop it off. That's not an authoritative map content source. What we really need to do is drive people to that fantastic place. So if you go to Google Maps Gallery, you might be able to go to a property like the one that the City of Edmonton stood up. Now, working with FME and with Google Maps Engine, the City of Edmonton was able to stand up a place where they can surface public schools, traffic counts. They actually have traffic sensors, and they can stand up some of the counts. A neighborhood crime map. The 311 example I gave from New York City, similar kind of thing, any of the service calls that the city stands up. And they can make this dynamic through FME. They can actually have this be real-time updated onto the gallery property. And this is exciting. And one of the things that we do that we think is kind of important is to make this kind of data transparent and accessible by others. There's a quote here from the city that basically says that we hope that more Edmontonians will discover our commitment to providing the information that we're serving out to the public. They're serving their public better by making the data more discoverable. One of the things that we do with the Maps Gallery program is we allow an authoritative content source like a city to be able to actually sub-license, and they have their own, a link to their own license. So if they wanted to use this as an extension of their open data program, they can do that. It's a great place to match that up. If you have any more questions about that, you can come and speak to myself or Dylan or some of our colleagues about the gallery. So what's next? We get questions a lot about kind of what we're excited about and where we're going. Visualization of geodata is really only to us about half the story. So far we've been talking about viewing at scale, serving at scale, discovery and interoperability, which is great. And viewing that kind of map data is amazing and it's critical. But we don't only want to just see the data. You don't just want to see your data. You want to know the meaning in your data. You want to pull out actual information. So we think that analysis is the next big kind of critical frontier. And we're really excited with our Earth Engine effort. You can have a look at the Google Earth Engine story if you search on it. We're excited at throwing virtually unlimited CPU hours at an analysis challenge. So in this example that we've thrown up here, this is a global map that you can go and visit that looks at global forest canopy loss. By automatically, essentially, we've thrown the Landsat data archive from the United States Geological Survey. We took all of it. We essentially built a cloud-free mosaic for the world. We were able to do that in a really short period of time, as opposed to the 14 years of CPU time that it might have taken on a local server. We were able to stand it up in a day or so. And by serving that out to the public, they can view a global cloud-free map. But what if they could do some analysis on it? What if they could do a standard NDVI, which is, for the non-remote sensing folks in here, it's basically looking at the difference between the red and the infrared to pull out whether there's any kind of moisture in, say, a green leafy tree canopy. Well, with that, we can actually make all sorts of really fast image analysis and image analysis maps available. You can see here the path that a tornado cut through Oklahoma. It really becomes easily available. If we can lend that kind of horsepower towards global problems like deforestation, climate change, maybe people could do some really cool things with it. So that's kind of something coming down the pipe from us that we're interested in talking about. Love to get your thoughts and ideas on it there. I want to wrap up a little bit with this question of how you plan to scale. I mean, as an FME user and as a SAFE user, you have access to a platform that basically gets rid of that last mile problem that Google ran into there. It's really exciting to me that we can work with dynamic data because the world is constantly changing here. Our partners are telling us that the useful maps that are standing up there have to be open, have to be dynamic, they have to be scalable, and they have to be interoperable. So we'd love to hear from you guys. There are 4 of us here from Google here today. If you have any questions or any comments, I'd love to take them now or speak to you afterwards. Thanks very much for having us here. Hopefully we have time for questions. I didn't get the hook, so that's a good sign.
Any questions from the crowd? Well, I've got one.
All right.
So what's the deal with the Skybox acquisition?
I knew somebody was going to ask. Okay, for those of you who haven't heard, this is really fresh news off the newswire there. So Google's agreed to acquire Skybox Imaging, who have low Earth orbit satellites, and they do a lot of imaging. We're really excited about this because it should help with that primary goal that we talked about early in the presentation about providing relevant, up-to-date imagery in our Google Maps properties. So I think it's going to be really great as a contributor of content into Google Maps. Interestingly, I think we're also interested in it because we have a focus. If you've seen a little bit about our Project Loon, we have a focus on bringing internet access to other places. In some parts of the world, it's really difficult and expensive to lay local infrastructure to put together all the pipes of fiber or cable to serve local users. You look at a place like sub-Saharan Africa, it's a challenge. We're interested in finding ways to use space-based platforms and upper atmospheric platforms to serve internet access locally.
Oh, wow.
And hopefully it can also help a little bit with disaster relief efforts like the crisis team.
So more than just watching Homer Simpson running around his backyard live.
Exactly.
Okay.
That's right. That's right.
Okay.
That's a good question. That's good.
Anybody else? I thought Teresa was going to, but
We have
yes, Bruce.
Bruce.
Self-driving cars. They're not for sale. Not yet. Not yet. There's a really cool. There's a YouTube video on it out now as well. Chris Urmson, who runs that program, just announced that we're into the development of a small group just for testing. We're really early in that program, but it's super exciting for us.
Are Google Fusion tables still out there and going strong, or what's the vision?
Some are still using it. We see Map Engine as probably a more scalable way to solve the business problems of Fusion tables. The question, for those who couldn't hear it, is what's the story with Google Fusion tables? We think Map Engine for spatial is probably a more scalable way to work. So I'd love to chat with you a bit about how to bring some of the platforms you might have built on Fusion tables over to a Map Engine.
So that has a database behind it?
Yeah.
Using GME for local infrastructure to push out your own web services and things as well, is that possible?
Sorry, say the question one more time, using it for?
Using it for a local SDI instance, for example.
Sure.
Pushing it out, and whether you can push it out not just through using the online GME, but through other services like WFS, WMS.
Right. Actually, that's a great question. So once data is in GME, essentially, and you might have used the Safe to ingest and basically manage the integration with your local GIS, you can publish WMS straight from GME. So anything that's in GME can be published out through WMS.
All right, I think Adam's quite a popular person. Let's have you after the break, or when we go to the break, why don't you hang around down in that corner there, and you'll be mobbed by all these FME fans that want to get moving their data. Thank you so much,
Hey, thanks
Adam.
very much, guys.
Yes,
thank you.
It was fantastic.
Thanks, guys.